Welcome everyone for our weekend activity of maintaining a Linux distribution. The recurring theme, the imminent release of our next major release of T2 Linux is greatly exaggerated, and despite the 2032 Linux distributions and RPM, Red Hat, Fox and whatnot, strangely constantly stuff breaks. Case in point, LCMS, and with that our recurring theme here of giving a open source patch and you have one fix a day, teaching everyone to diagnose and fix and patch open source bugs, marginalities and features, and you will receive patches for a lifetime. So let's take a look. Also, so this just built, right? So that is crazy. The Spark stuff, and I saw that, but by the way, so what we will fix in a minute is a little CMS, LCMS2, a little color management system, and that we ship by default. And the crazy stuff is I now reduced with all my massive undervolting overclocking. Maybe we have some other real bug here or whatever, because I now further reduced my undervolting and overclocking, and it still broke randomly there, right, with GStreamer, and it's like, I'm not yet at stock voltage and stuff, will be interesting to see, but that also means, I said it before, right, building GCC Clang, and specifically for some strange arbitrary reason, Spark 64 appears to trigger and hit most system instabilities, which is crazy. I mean, it could still be some real bug in something, but I mean, it could still be software bug of some sort, but probably most likely not in GCC. That would be more like Linux or whatever. We will see. That is absolutely, it's like, yeah, how do I waste my time with overclocked or other software marginalities? Anyway, so how to fix open source stuff. We are cross-compiling this, which may or may not be the issue. So the first stuff, so this is slightly T2 related, right? Our amazing Linux distribution here with this sandbox and debug. If you build this with make install, of course you just extract the tarball, build it, you probably have some bug reproducers and stuff, and go from here. For T2, we built an ISO, it stops with some error. I go here into the sandbox, run our debug script for the debug to recreate the exact sandbox build environment state, and then LCMS probably. So then previously it was always make, now I always need to check what did we run. Maybe I should actually change the debug environment because nearly each time I grab for running to figure out, so this, yeah, this did run with Ninja? What the heck? So run configure, I mean, maybe that's a bug. Wow. But yeah, if I repeatedly do stuff for a decade, then probably I should automate it. So one quality of life improvement would actually be adding grabbing running to the debug script of T2. Then if you enter the debug environment, like it just comes to me, right? I don't script this. I did it the 10,000th time, and it's like, why don't we have that in there? Anyway, maybe that is the real issue. So we have here some undefined references, which now we need to figure out. So the bug is, of course, each time different, right? What you need to really practice your brain cells and think, right? Not like random Googling. I mean, you could Google, maybe I Googled it, but yeah, random Googling usually doesn't bring us a fix, right? So, I mean, you could, of course, Google what does. If you're new to this stuff, you could, of course, Google what undefined reference to something means. Of course, usually not with all the stuff. So that means the source code was compiled in one way, shape, or form that either that is not exported. So CMS, of course, color management system, free tone curve. What this is usually not important. So how this usually appears is either modern LTO linking, right? Often LTO link time optimization with whole program optimization often optimizes things away. It's by the way test plugin here, right? Is it only? So it could be LTO, which I believe I might have already disabled. Let's check if we even built. I think I disabled CMS2 last week already. Did I say LTO? Oh no, we didn't disable LTO yet. Okay, so with my experience, it could be LTO. No, LTO, that would actually be a small fix. You could always fix it if it's LTO related. But it's often tricky and non-trivial because it still fails. All right, maybe I did no LTO and I didn't fix something and then I didn't commit this. This might be. Also, yeah, pro tip, if you run into an error like I myself a week or two ago, better fix it instantly because otherwise 2 weeks later you still have it on your plate. Okay, that is apparently still the same. It could also be simply mixing, like linking, especially in our case of cross-compiling, it could simply try to link the wrong binaries, which would actually be helpful if we would, like, yeah, a couple of errors and more. So yeah, basically undefined references to maybe everything. And also, that is a frustrating part, right? I do this for 25 years, and now just the previous video, we increased our feature and bug bounties, right? More economically viable to pay you fixes and teach you to patch that and receive patches a day for lifetime to come. But like 25 years later, 2032 Linux distributions and God knows how many Red Hat forks, and stuff still does not just build. So yeah, usually, also pro tip, usually the real errors at the beginning. So it uses the Spark GCC, so far so good. We cross-compiling for Spark, but that doesn't matter. I believe it fails for more, all, if not like most, if not all, cross builds here, undefined reference. I wish, by the way, that this errors would be more useful. Also, recurring pro tip, right? I said this already 100 times. Diagnostics, and diagnostics, whether it's Linux kernel, GCC bin utils, and everything, installer, right? LVM, diagnostics, and the only replacement for diagnostics is good diagnostics is better diagnostics. Just check. And common link ICC. ICC is international. Is it International Color Consortium or so? So it's basically a lot. So we could next, what does it even try to link? So next, then analyze what it tries to link. Common xget opt group. Maybe we take a look into the log files. So far, it looks a little bit strange. This also has Meson. So one issue is also maybe it doesn't even support building with configure anymore and prefers Meson instead. Something of that sort. So it could be that this configure stuff simply does wrong things together with Ninja. What does it even build? So it does configure. We run Meson. We run configure for no good reason. Is this libdir even correct? So it builds something with, also so much to the futures now, right? Recurring theme, make and autoconf was not enough. Now we have 24 2 dozens of build systems and all suck differently and still can't build things. So it does build all of this without warning. That's a good start. Is this the right? Spark 32 plus V8. Is this our, what did we, right, this is our correct. Because I also built 64-bit fully native there. I mean, we could try, so in general it looks okay, except the libdir. The libdir look. All right, because we default to 32. Okay, the libdir is also correct. Okay, so double check the basics, right? Libdirs and all the stuff. So that looks all right. The next thing would then be, so what does it? It builds some, it's also, I should scroll so many error, basically more error messages and source files. Here's also fail. It failed util PSI ceiling target generating here some symbols. And it linked, so it probably should be in there. Does it even? Is this a, yeah, this is a, it's interesting that it, maybe it saved the build, yeah, probably it saves the compiler output. So usually Makefile stuff doesn't do that, right? In Makefile you usually see first the program diagnostics, which GCC Clang. Here apparently because it printed failed first. So that's some modern stuff. So what does it link here with the library? So complex rpars, link and whatnot. So that is for, did we, so serve, apparently there, right? Does this look about, do we have here any library here? Source SO15 that looks about. Did we add this with object? Yeah, hopefully, right? Or did we? So do we have that? An object here, why did this not? Oh, this was wrong. Spark. If this triggers you, it happens. It occurs the same for RISC-V 'n any other. No symbols there. Symbols here. Where is, this thing does not have symbols. So what you expect here is this T or symbol table? No, that's probably the issue. Somehow it looks that probably here's some symbol file. What is it? This is also empty. That's certainly, that's unfortunate. So how did it link that? So it looks like it doesn't export any symbols. Let's double check that with maybe just some file. And that is the depressive part, right? That for 25 years you fix things and at the end of the day trivial stuff still doesn't build. Also best correctly using those. Were they all inside there? This how this. That's also the thing, right? With 2 dozens of build systems, each time you need to get familiar with yet another one. So here's stuff undefined, or here's also hidden. So this is compiling with hidden symbols by default, just that it apparently does not. So what that is some modern symbol visibility. I don't think we had this 20 years ago. I believe that was somewhere new. 15 years ago, so that's some new modern GCC hidden. When were they introduced? As far as I remember, 25 years ago, just everything was exported, and control for this probably arrived only 15 years ago. So, but yeah, if you remember more of those details, then tell me. So undefined stuff can be correct, could be correct, because that's simply coming from other files, right? So I guess everything is hidden. We could basically check. So there's something going wrong with symbol visibility. Undefined reference to open profile from whatever. Can we do all files and grab? Yeah, that's hidden there. Text hidden. So it's not exported. So what this means, it's SVC. It doesn't export anything. So something like, yeah, 2023, and that is absolutely mind-blowing that we still have, it's like 25 years later, like how can stuff still be so broken? So we could try if it builds with configure without Meson. Let's give that a short try. So there's something severely going wrong with their build system and sources. So if you do nothing, everything exported, so that normally you control visibility like hidden by default and then only exporting your public API so that you don't export internal functions and symbols and stuff, for better performance, for not clobbering namespaces with random stuff, and all those things. So no LTO wasn't it for now. I mean, maybe this is a crossing, maybe Meson does something misdetect. But yeah, the other 23 build systems sucked. We had to reinvent Meson and whatnot. Run Meson 0, I guess. Let's build this again and see what happens. If this, so normally fixes are to fix something for real, but if a build system like entirely doesn't work, of course that also doesn't make sense. So this fails differently. Cool. How does this feel? But sometimes the fix is to use a right build system, right? Otherwise, usually you patch sources of other common things are C library things not found because the C library gurus clean things up. Like previously, some functions, some symbols might only be visible accidentally due to other includes, and they clean up include errors, so the namespace is not, like the global compiler namespace is not unnecessarily polluted with random symbols, and or they remove things because they were GNUisms, and 30 years, 40 years later, it's like, yeah, no, we don't like GNUisms anymore, or we want more standard conformity, and so on. Build Spark, also we still build there, 32. But that's the thing, right? Before you start, you don't know, illegal instructions, that is my, okay, now it failed differently, that's a new thing, this is my, okay, so without Meson it works, yay. So that was an easy-ish fix, so much to use new build systems, they are so much more amazing, except if they don't build. So, I mean, that was an easy fix, but sometimes stuff is like, other people could get frustrated who often do not get it to build. What we, this is also, here's something really strange with the system now. Ah shit, I didn't want H. I should capture the VGA out, but I didn't start it. So basically, what I want to do also dialing. So yeah, you should. So yeah, shall I subscribe? I need an assistant and more video equipment. Entering a BIOS, dialing further. It's absolutely bizarre that every other architecture builds, so I had previously nearly 100 millivolt, 0.1 volt. I'm now at 0, so I'm not 35. So from nearly 100, like 95, 90, but 100 works. Let's choose 0 here, and I'm already down to memory only 58. Let's like maybe auto that. And who needs performance? It's absolutely, I mean, maybe it's a real software bug, right? Sometimes you think it's your overclock, and then this certainly will hamper performance a lot. Let's make here all cores negative only 4, so that is nearly no overclock and undervolt anymore. I probably, you know what but I mean, it would not be the first thing, right? What was the author of Dragonfly? Matthew Dillon or so? Matthew Dillon, he found probably 2 AMD correctness marginalities. Where is even freaking team? I didn't post yet. We DDR5 retrain because we majorly changed stuff. Where somewhere was team? I just saw the other week here. Yeah, Matthew, I was spot on. So he found probably at least 2 Matthew Dillon AMD bugs. It would not be, I mean, it is crazy reproducible, and only, so far only and that is crazy, right? Extremely overclocked and undervolted, the same as nearly no overclock undervolt. I probably, like pro tip to myself, I probably, I know we posted, I probably should run this complete stock. I could also run another system, but then there is too much software differences to not trigger it, right? That makes no sense. I mean, unless I would, maybe I should further migrate to a Storia area network architecture and be able to just boot the same network system, because right now I've booted that locally here. And this way I can't be sure that I reproduce the same issue here. So that is, let's check this. My BIOS, you can't rely on DMID code, that's a very low tech. By the way, I really wish, with Linux being the #1 server operating system and soon overtaking Apple in personal computer market share, especially with gaming on the Steam Deck, I really wish all those level hardware details would be more directly exposed, and with cooperation of the vendors, so that we could, like similar to Ryzen Master, AMD Ryzen Master from Windows, and other, like if there were like real top-notch perfect standards to expose all those memory timings in Linux, because right now you can't. And there is not even a vendor specific tool. They should have trained to, yeah, 5600, this is XMP. And so also best checks this, right? I know that for this board, the BIOS filters in, but it's voluntarily and good gesture by the BIOS just to fill it. And you don't have, this is also wrong, right? So the voltages here, the BIOS updates, it's not updating it's not even updating the serial number, I guess. Maybe this is correct. Yeah, this is correct. But it's probably not even filling the serial number, the BIOS. And it's also not filling the voltages, because I mean, maybe this voltage is correct, but no, I think it isn't. I think this memory is nominal 1.2 volts. Is it printed here? It was printed on the website when, like 2023 or 2022, you don't have your memory voltage on. We could Google that stuff. I think it's 1.2 volt, and I run it with 1.3 or something of that sort. We probably could Google that. 96, yeah, that's correct. And if that, whatever. 106? No, no. So this is bullshit. Yeah, 200. What did I pay? Probably I paid 300 something. Anyway, we only wanted to check voltages, right? Yeah, 1.25. So that's what I remembered. 1.25. So like, yeah, so much to. This is PC technology, right? At its finest. Not I really wish all this stuff, like what is Microsoft, what are Microsoft, Intel, Micron, Samsung hiding, and what are they freaking doing? Except nothing. So let's continue Spark builds and let's see how often this, do we have watch in, no we don't. Well, it's not yet that hot, but I only came recently into the office and I'm not yet building that long. The problem with such bugs, like random Heisen bugs, is, of course, as you've seen, you build, it breaks randomly, you continue, it builds, like, so it's not very helpful. I probably, did I build this? Here is my, I've somehow built the wrong target here, I guess. Yeah. Yeah, it's not even that hot yet. I don't. Yeah, it's crazy. I wonder what we will find if we ever. So this stuff, Matthew Dillon. I think he found two, maybe one TLB. This bugs are of course extremely crazy. I would not want to rule out. This is also generic cross-compile marginality bug. And this could be, on the first glance, I guess this should build. Where's the error? Oh no, this is a outside. Oh, it started. Ah, okay, GNU-TLS. That's a crazy thing. That's an absolutely crazy thing. So that is not overclocking. This did run the Xorg server, and I have also, like, of all the also pro tip, debug the most obscure level shit. I've surely 100 times, like no kidding, like not like a dozen times or 2 dozen times, for over the last 25 years I've surely 100 or maybe even 1,000 times debugged the most crazy low level shit. And pro tip, do it. You learn so much. The most obscure things happen. This is also one of those super obscure things that occurs on some cross builds. And so this started the Xorg server, and we will probably see this in the log. Because I already did this similar things, not this, but I debugged similar craziness too often that I'm like, pro tip for you, if you never or rarely or only seldomly done it, do it more often, like until you reach 100 or 1,000 times. I'm already a little bit tired of this, and I have simply so many to-dos on my plate. So probably if you send more patches and patronage and so on, like if you use our bounties and earn some fixing patches, I would have more time to debug such stuff. What's happening here is I diagnosed this a little bit for 30 or 60 minutes some year ago. And what happens is, this is a new thing since we switched to Dash as the default shell. I debugged, I benchmarked this 2 years ago. Dash instead of bash with D instead of B. Some 11% faster, and certainly with all this embarrassingly long single-threaded configure stuff, 11% faster configure. I take it every day of the week. And since then, like some configure scripts with probably non-standard or otherwise quirky or GNU-isms of like, it only works when you run it in bash because tricky or potentially buggy out of spec shell scripting, they managed to accidentally run the Xorg server, usually by somehow, like instead of executing a binary, like reading it in or evaluating, like eval some file with executable. This is why I debugged it and then I stopped. It's like dude, this is so stupid. What I usually do, I wonder that this occurred here because I built this already often. So this mostly happens for PowerPC and Spark, most likely because the ELF, because as I said, it's somehow evaluating the content of a binary executable or something of that sort. And for some architectures like Spark and PowerPC, usually the beginning of a file results in crazy text patterns that happen with dash to execute X, and like there is an X with the right combination of hash and shebang and X and whatnot, that it somehow randomly accidentally runs the Xbox server. Super crazy stuff. What I usually simply do, okay, this still builds, I pressed the wrong button. Also need coffee. What I usually do is switch that to run with bash instead of dash. Ideally, I should spend another hour or two, or even I might even need to spend a whole afternoon to debug in what special. The problem is configure script usually 30,000 lines, and then like good luck debugging. Like first debugging at which location, like which source code location, this strange stuff occurs, and then which even was it, GNU TLS, and then finding the exact syntax. It was GNU TLS, right? GNU TLS, that should be this one. It probably should occur again, this should occur reproducibly. But yeah, I always said it, I was not joking, cross-compiling T2 is the best system stability test. Like basically companies like Alienware also could actually use cross-compiling T2 Spark as their most sophisticated system stability test. Yeah, that occurs reproducibly. Ah, darn, it occurs reproducibly, but then we did not run with capturing the temp of S. By the way, is it on Wikipedia how many? I think in the meantime he found 2, by the way, from previous Amiga fame. I think in the meantime he found at least 2. So yeah, most recently got a number of headlines around CPU erratas. 2007 was after Theodorat. OpenBSD raised an alarm around the seriousness of some of the errata of Intel Core 2 family, independently evaluated Intel's errata and did an overview of Intel Core errata as well, suggesting several of them versus series weren't avoiding any processor where the issues remain unfixed. Has since been a fan of AMD processors and subsequently in 2012 has discovered a brand new deficiency, marginality in some AMD processors. Continue to work. I thought he had at least found 2. So it's still the same issue, I just had to have the sources. And where would we... Yeah, configure, as I said, configure sh, somehow do whatever crazy stuff instead of doing it's like, yeah, 2023 shell scripting, so amazingly secure and still not conformance that it accidentally runs your Xorg server. We could, of course, like sandbox it more or have an X wrapper which traps that of like, actually maybe I put this on my to-do just for it's like, yeah, you can't mix this nonsense up. So Go script, I guess we still have instability. So this is unrelated, right? This is just FE2 Spark builds. This is here absolutely crazy. This, I mean, we are approaching nearly stock, right? So, and also it's illegal instruction, right? Why would illegal instruction? I would not be surprised if this is some Matthew Dillon level of CPU marginality. So how to debug this, right? Staying on topic of this video. Probably it would be best to patch the Linux kernel to log occurrences of illegal instruction and then capture. I mean, you might or should probably most likely be able to runtime, like maybe eBPF kernel JIT patch that or whatever. But we could simply modify the illegal instruction and segmentation fault handler of the Linux kernel, like simply 1 or 2 hours later, and like basically print out. I would start with printing out in kernel any occurrence of illegal instruction. I hope that would not be too many. Of course, in some runtime tests could do that, right? So you might get thousands of false positives of stuff. I mean, on Unix and Linux, usually programs use CPU info and proc CPU info and CPU ID instructions and stuff. So maybe they shouldn't, but theoretically, illegal instruction could be a valid thing of a program to do, right? To try run stuff and see if it works. Although most software usually doesn't do it like that, but I wouldn't be surprised if some OpenJDK, whatever Java stuff does it, or other such stuff. So most likely, so that is, it's absolutely crazy, right? I'm nearly, everything else builds, memtest runs, everything else runs perfectly, everything else builds perfectly, and Spark 64 randomly errors out like this. Absolutely crazy, right? There must be some really AMD hammering instruction sequence in just this GCC cross compiler. And I'm not even building with native instructions. I'm building with whatever the system compiler default is. I think I benchmarked that recently, 6 months ago, and building the cross toolchain with CPU native didn't change any measurable performance. So, but theoretically we could do that. But I guess it was no win-win. Anyway, so let's patch this configure. So what I usually do as a quick hack is dash bash. Yeah, let's see. Usually this is enough. Let's see if it is enough. Hotfix bin bash or so. How often did it do that? Like a couple of times. So yeah, there is some kind of pattern in the configure. That probably also means that some configure checks do not do the right thing. But yeah, as you probably guessed from soon 5 years live on YouTube, the amount of Firefox that is correct. We can't build this yet. Previous video, we still have some Rust and Cargo to patch, and LVM, of all things. But what we could do is Firefox builds, I believe Firefox did build with Rust and Cargo for Spark 64 version 9 64-bit user space, which we of course in our amazing Linux distribution support among all the other 33 or so primary release variants. So we could take our SunT4 out and see if we could run Firefox on that just as a pre-test to, like, probably we first should get that to run. Like, it builds, at least as far as I remember, it built last week. But I've not run this, right? The last time I've run Firefox on Spark was a year ago, or 2 years ago. Is this again illegal instruction? It might be, so it's probably another reboot is in order. Also, yeah, pro tip, before you build systems and debug stuff and so make sure your system is stable. Would not be, where's the error? Most likely internal compiler. Absolutely crazy. This is absolutely mind-blowing. This is absolutely way too reproducible. It's crazy that I only realized this a year after. Yeah, like precisely, like basically I have this CPU a year ago and now realized, hey, it's sometimes illegal instruction. AMD Ryzen 7950X. It's also like randomly, right? Oh no, it. Let's probably stop this build. Of course, you find only valid discussions with, like mostly, right? This is pretty reproducible right now. Usually it builds in the second time, but maybe if the CPU is cooler then. Yeah, we are somehow up to something. Maybe I should buy myself, now that they are cheaper. Yeah, I next need to, first need to diagnose. I mean, the question is, AMD probably will not RMA and will not be happy and RMA and CPU for, hey, I get random illegal instructions. I could buy a second one and send my first back with stuff, like shady business stuff. This totally doesn't build right now. What, the price increased again? Hey, it was once $499 already. Why did the price increase again? Hey, it was even less previously. $482 already. I mean, this price is crazy, right? This is precisely half of what I paid on launch day. Obviously, dumb YouTuber and Linux enthusiast buys overpriced CPUs on launch day. Yeah. Launch day. How long did it take? So, oops. Probably. Even at Christmas it was already. Wow, this was before. Wow, before, like, just within 2 months it lost a third of its value. Yeah, previously only with this YouTube stuff. I mean, I never brought that new stuff. This is actually freaking reproducible now. This is crazy. Usually it wasn't that reproducible. Usually it continued building. I mean, the thing is, it could always be a valid illegal instruction. I doubt that. It was not the pattern previously. Okay, let's shut down. I mean, we had this with whatever Ghost script previously. Did not build right, unfortunately. If you want to motivate me to get out a second capture dongle and capture that, don't forget to share, like, and subscribe. Patreon, GitHub sponsor. How long do we live stream? Like, alright. Yeah, obviously this live stream would be more engaging with. So then let's disable boost scalar auto. No CPU boost override. No curve optimize. What is it even? Curve optimizer. Memory. Maybe I mean, there's not much, right? We run this basically XMP now. So there is not much left. Is there anything left? I mean, except I run still dynamic vCore SOC plus a little bit. You know what? Let's basically I only run this. So I mean, on auto it should surely be 0, right? Yeah, my love-hate relationship with modern BIOS stuff. I could actually probably run the memory with a little bit less voltage. Not that it should affect something. So all the memory timings are now auto XMP. You know what, maybe no low latency and no high bandwidth. Yep. It's the fun of running IT. The fun of IT. The thing is, can I even, so I'm running this SteamDock deck. I run that with 10,000 megabit. The problem is I have there already a, so here the problem is, will it even, why are you, oh, this is the same device. The crazy stuff is this is supposed to be a 10,000 megabit, like 10 gigabit hub, but it doesn't show like this. I wonder if this is some fake advertisement or, okay, we DDR5 memory trained, amazing. Because I have here a second cheap HDMI capture dongle, maybe the next time I should do it. So if, I mean, there is not much left, right? If this still, so XMP, so this is as rated. I mean, that is also why I didn't sell. I could have sold the second as first expensive kit, but I kept intentionally not only, I mean, right now I have a lot of vintage and retro stuff, but I don't have excessive, like, except vintage and retro, I don't have excessive modern stuff, right? I have one AM5 board, which we purchased, nobody sends me one for free yet, right? And I kept this memory just like, either we built a second cheap system for production or testing, and also such stuff, right? You have some instability, and I could plug in the other with less, potentially less capacitive load and whatnot, and different timing. It's also other they use different. I probably should have penciled it on the box. They're different vendors, whatever those were, like different memory vendors. So what does this do? And yeah, such kind of stuff, this still fails. Wow, this is, okay, some provisioning we don't have. Yeah, I probably, yeah, if we want to sell a professional business enterprise SPARC distribution, I probably should. It should only take one afternoon to patch that, probably. So it's, yeah, that certainly sucks with some random illig instruction, and then you can't differentiate this between, is it some random Heisen bug? So much to overclocking and stuff is evil. It's like, yeah, with the problem with this modern BIOSes, you can't even be sure, because I now have voltage on auto, like previously I had it on normal and whatnot. Okay, let's wipe this build. And redo that, just be on the safe side. OVM2, no, so this still occurs, is absolutely crazy. This occurs, I have two builds here, right? One is, if you're wondering why do I have two SPARC builds, because we officially support two SPARC builds with our amazing Linux distribution. One is 60, like basically three. One is pure old V8 32-bit, user space and kernel for old SPARC station and stuff. Then we have Spark, yeah, build. So, and we are at stock levels, right? Good that I didn't deal it or how do they call it? Lab. Good that I did not deal it or lab the CPU yet for better thermals. I usually only had this with system instabilities. I mean, that's the thing, right? Who knows, like, in general, it works well now with latest BIOS, except this, so yeah, whatever recurring theme, right? Who knows what tricky stuff the BIOS does and what the CPU does now. But this is... So we are running without curve optimization. We are running this memory at XMP stock without bandwidth and low latency, further BIOS auto tuning. I mean, maybe... I mean, it is theoretically possible. I mean, what the best test would then be to have a second 7950X and switch the CPU over, right? Maybe one core, what theoretically could really be, is that one core really has some deficiency. And like often when this occurs, like this is why next I would need to instrument the kernel. This is of course something you don't see from Windows people. Windows people only like, they cannot modify anything, and if it crashes, they only change the voltage, the timing and stuff. So of course some open source operating system, BSD and Linux and stuff, you can actually further debug that. Because right now I don't even have... I know I deleted it anyway. We should see that in like 1 hour or so. Did GCC, I mean GCC printed out, I think, a backtrace with symbols. But what would help is if, I mean, it's one executable, right? It should not be like, it should not be miscompiled, right? Otherwise, it's like, yeah, you have a broken compiler. But why does it then, I mean, there could still be thread local stuff and multi-threading, but why, if there is not something either overclocking, glitchy, or otherwise broken in the system, why does it build like usually on a second try, right? Most likely simply running on another CPU core and thread. Yeah, so that was at least LCMS. Back to the topic of this video. Did I actually... maybe we quickly check the history of that. Did I had... Because sometimes I enable stuff that previously was like fixing it back and forth. Does not appear to be the case. Let's quickly build it natively so that we can update the cache file. Yeah, but this CPU bug is crazy. The other CPU bugs, like if it is a CPU bug, I mean, it could also be, I mean, usually it builds, so it might be, that's also the thing, right? CPU is obviously so complex, like a year later you notice potentially some manufacture, like after you optimize for a year, stuff is so optimized, only a year later you realize a CPU execution marginality. Crazy stuff, really. It could also be that previously it was not there. It is also always possible, who knows what they broke with microcode, right? Although then it should still behave the same on all threads and cores though, but no. But it could still be possible that it was... Oh, by the way, what is this? Did AMD not promise some microcode update for security? issues? I actually built with mitigations off. Maybe some mitigations hide some stability. 2023, everything is possible. So only constant exchange and regressions and CPU marginalities, CPU bugs. LCMS2. Okay, that is then without Mesa. Okay, that is indeed significantly, like, previously rounded down to 0, so that's a much better cache file of. Yeah, that certainly needs only one manual tweak. So yeah, this is kind of sorta, it depends, right? Sometimes it's just disabling a less than stellar build system. And probably I probably should benchmark how much it was with mitigations. I think it was, some people said with modern AMD Intel it doesn't matter that much anymore, but it, or even is faster with mitigations on. But I measured it some months ago and it was slower. I mean, I could further decrease memory clock, right? But I don't have the highest hopes. But nailing this down will be is easily a week-long work that obviously nobody pays for, right? Except your viewership. Maybe I should live stream it, but it would obviously be a tedious, boring, and the problem is, of course, that you can only guess inner workings, or like from like approximate inner workings from CPU talks and so on. So it's not like you can microscopically debug the CPU execution. Bits. Speaking of bits, the new users release probably. Somehow our data does not yet reliably track this the most. 0.33 last month. Hey, slight update. I probably don't have all this stuff. Some more good other stuff built. I mean, all this massively de-overclocking and de-undervolting did not change the segmentation fault behavior yet, right? Let's build Yosys. This is a brand new installation, so probably need quite some other packages. So what was that a decade ago? Wow, time flies, it was already a decade ago. I can't believe that, absolutely. Confirmed CPU bug that they analyzed, going to quote the first paragraph that gave some info while updating their revision guide. Without any confusion, they can finalize their wording for the entry or putting. I'm just quote, AMD has taken your example and also analyzed the segmentation fault and the fill sons and loop code. We confirm that we have found an erratum with some AMD processor families. The specific compiled version of the fill sons and loop code through a very specific sequence of consecutive back-to-back pops and near return instructions can create a condition where the process or incorrectly process or incorrectly updates the stack pointer. What? Processor. There's also exchanged a few emails to try to come up with a good test case. Owing to the difficulties of reproducing the bug, I constructed a fully bootable Dragonfly operating system test case, USB image, and verified that the bug was present. On their test box, using that image, AMD was then able to reproduce the bug using that image on their own machines. Over the last few months they have been working through the possibilities and today emailed them confirming that it was indeed a CPU bug. Pretty stoked, it isn't even a guy like them to find honest to good hardware bug in a major CPU. Cool, where was the original? Users also built, amazing. Then let's continue with our Spark goodness. So it is very well possible that some very specific instruction, I mean, maybe it is some, I mean, given it's, I mean, I'm only speculating here, right? If it's really not my system, simply I mean, I could, the best way to reproduce it, so if I rebuild the same T2 on another system, like, as I said in the beginning, it's a different base compiler, system compiler. The best would be to clone, ideally even boot the same Linux kernel. Yeah, best run totally identical software. I mean, in the extreme case, you could take out the NVMe drive, and I mean, you could also clone it, but yeah, we use Unix, we got this, we're not like Windows users taking out the NVMe drive. We could DD clone it even over network, right? Plug in a, even on the second partition or whatever, but or second drives, like rsync, like DD raw file, copy the whole thing there. So that we run the exactly the same software, because otherwise, like if I would just build it on a 5950X system here next to me here, it could simply disappear by using slightly different kernels and whatnot. Given that somehow the Spark build is so far the most fragile, maybe I should really resort to use this as like nothing like sys, like previous video, right? Stress app test. Nothing like stress app test. Was it stress app test? I always stress app test. Nothing like stress app test with compiling to 2, right? There's even yeah, here. Matthew Dillon 2011, over a decade ago. So this is a little bit similar, right? Build world loop segmentation for, although maybe was theirs fully reproduced, I mean fully reproducible. After struggling with this issue well over a year and really pushing hard to track it down, I was like, yeah, so much too. Did I say it might take a week? It's like, yeah, other top-notch AAA state-of-the-art operating system developers struggling with such an issue for over a year, right? So much. Can you track it down in a week? Maybe not. Maybe it takes a year of off and on bug hunting. Finally able to come up with a test case running CC1 from GCC 4.4. Oh man, is that old? In a loop. Oh yeah, it was too soon. Finally able to come up with, it's like, yeah, in a loop. So probably it only crashed sometimes, right? So me running this again, it's like, it sounds pretty similar here. I was finally able, so yeah, from GCC in a loop. So yeah, so much to their stuff might not be as reproducible as my stuff here. With my thing, like continuously running GCC, and they also, right? Like running it once, it builds, running it in a loop and it occurs in 60 seconds. Prior to finding this case, it would take anywhere to 2 days with 48 cores to fully load it to reproduce this failure. So this is pretty similar actually. Only CC1 from GCC 4.4. This is also why I say it might go away as another compiler, right? All my other systems like HPPA, IA64, everything else builds except, like, the system is fully stable except the Spark builds randomly break, right? This is why, of course, the GCC is different for all the architectures, right? The GCC have the code generation and like every architecture specific thing built in, right? So just this memory pattern of instruction sequence of whatever it's going on there is triggering that right now for me, right? Repeated runs with the same arguments would not reproduce a bug with any consistency. This is absolutely the same what I see right now. In other words, it could not be a bug in CC1 itself. This would further, yeah, I mean, it could still be a kernel bug, like sometimes clobbering up something, but it can't be just it, or I mean, it still could if it's doing some threading and like probably could analyze it. Like if it's not doing some threading, like basically if it, because with threading, with asynchronous stuff, like maybe some stuff finishes sooner and triggers whatever, and child process handling and whatnot, and but even single thread stuff theoretically, like if it depends on like what data, I mean it should not write a compiler. It's not like some pseudo random not random number generating stuff. But anyway, I'm just thinking about what, I mean, the 2023, the most logical explanation of random illegal instruction is actually the CPU having a bug, right? Like, hey, what, it failed here. How did it fail? Tell me illegal instruction, right? Yep. We have that probably should be this stack trace or something, right? Because this is internal error, so that is like here. So internal error is only the signal illegal instruction, right? So that probably is just switched retries. I mean, we already fully loaded. I mean, I could try to see if it builds a second try. No other program was failing due to this issue, that they could determine only CC1. That's the same, right? Only that Spark cross compiler, right? All of CC1's failure occurred approximately in the same place, moving around a little based on numerous factors. Also, like, does it occur on one single instruction? No, of course, modern, out of order, speculative execution and stuff, right? But it occurred approximately in the same places. This is what we need to determine next, right? Most likely. I mean, maybe we could use that printout. I probably should have saved it. All of thought LC, Wolf, the fill, sons and loop, first dumb son called for function, GCC 447. The result is a segmentation fault, bus fault, or fault related to corrupt program state, causing the compiler to run internal compiler, failure, error. Similar to me, for me right now on this machine, for this build right now, it is illegal instruction. I probably should make a dedicated live stream with just that, right? I mean, that probably good. Like clickbait 2023, financing CPU bug hunting with clickbait, not clickbait on YouTube. Failure has been observed 3 different machines, all running AMD CPUs, Quad Opteron, 48 cores, Box 2 Phenom 2 X4. Hey, I still have those. All running Dragonfly, however, I believe it has been discounted the OS as a possible source of the problem. See below. Particular failure has never been observed on an Intel CPU. Sandy Bridge consumer bug reproducibility bug is extremely sensitive to REP, RSP, changing the code base, little similar stuff. Anyway, Let this build for a minute. I tune back when this fails next. See you. I pause the live stream, leave it open. And it failed as expected, so that build is still going. Let's see if it failed exactly the same. What I probably should do, where is the, was it? Is this even, I don't think it is the same function. It is again tree switch conversion, right? I should start saving those. So probably I also need to I need to organize better. Should we, before now we name it MD 7950X Spark 60 GCC Spark 64 random ice. So that was that. I had another. So let's start collecting. So probably the best test would be, instead of rebuilding everything, which takes a while, just best to continue. It's also similar to Matthew Dillon has done, then running that in a loop. I guess it built already. What we could also do is we could maybe also, another good thing would be to capture Z1 file sources and build them in a loop and like see, like it should obviously always yield the same result, right? So basically everything is like reducing the test case from embarrassingly massive sources to just one file. And then like similar to Matthew Dillon, DragonflyBSD builds this, like a decade ago, builds this in a loop and see, like, it should always succeed, right? Like memtest, like basically a full system stress thing. It's like, yeah, freaking completely built, right? So, I mean, I'm near, so we have no curve optimization. We have stock, I mean, so that's the problem, right? Whatever BIOS automatic, stock BIOS automatic auto voltage. Memory is XMP with not even bandwidth and low latency. If we run this in a loop, it should come out of CPU cache anyway. It's absolutely crazy. I mean, even if this cross-compiler is not perfect, it's usually succeeding, right? We could actually... So how would you run this in a loop? This was... Which file was it even? So this is unrelated stuff, right, of parallel build thing. So it should be this file. But it happened also with Ghost. It basically happens with every random package, right? So again, it built, right? Touch that. Was it verbose one? Does this? What was the file name? AMD GPU GFX underscore. Did it not build yet? And the CPU is warm but not Yeah, not warm, but 91 degree. We are also, like, usually I run cooler and so on, right? We run with more, like, I have it usually undervolted the heck out of it. It is of course also possible the infamous your CPU degraded, right? I've only run it undervolted and overclocked, like overclocked only with dynamic, like max boost override and curve optimization for undervolting and better boost. So like not all core, like only AMD controlled, like should be safe and stuff. Was it this one, right? That is a little bit long. This should be all of this here. That probably doesn't GF, because this doesn't paste with modern Tmux and stuff. So that build. While this thing do nothing, I mean, we could do echo dot, like also no new line dot. Let's wait. 2023, you do that. I mean, what we could do next is, like, if this succeeds, it could be that it only occurs on one CPU thread or core. We could, of course, manually trigger that, right? We could either in parallel do that, like CPU affinity, CPU task set or whatever. Yeah, task set or whatever it was, previous video. It builds surprisingly long, right? And also we have all cores stressed, right? Other stuff is building. We could, because right now it's like we have the CPU fully loaded with building LLVM, and that may or may not be ideal to trigger. I mean, it happens under medium, low, or high load anyway. So, but I mean, you've seen it. It built most of the kernel and other packages, and then it sometimes occurs. Is it here? Is it the right thing? KCC, yada yada yada, blah blah blah. It should be here. GFX v9 0, GFX v9 0. And so it should not be the user mode executable, right? And welcome everyone. If this sometimes break, it should be, should. It's most likely a kernel or CPU bug, maybe CPU bug. It built surprisingly long, right? So much to Matthew Dillon a decade ago. I had to build it for, how long was it? What else did they had here? Efforts at finding a kernel bug that wasn't a kernel bug. I now believed, so they built a decade ago, believed and found a CPU bug. The following efforts were made to determine whether Dragonfly BSD kernel was responsible for the bug. Most of these efforts occurred before the fast reproducing case was found. It built surprisingly long. They tried pre-faulting. There were other bugs in the Dragonfly MP operations. These subsystems were completely rewritten and commented in the course of the research of this bug. Pre-faulting all stack and text pages and also forcing malloc and B0 to the allocated space change no effect on the bug mechanism. All user kernel transitions except BIOS SME, which they have no control over, recorded. So saved RIP and RSP. Like, it still freaking builds, right? So, I mean, so often we can build it after it failed. I mean, maybe it's... I mean, maybe it is memory stability after all, and it needs more memory pressure. What means CLI'd? Command line interface? Maybe something. I wish the people would more often like abbreviations in the context of your custom abbreviations. Return to use case code in the kernel was modified to intentionally smash the AMD RAS return address stack with a chain of 28 core recursion and returns because it had no effect on bug. All user kernel logged the TSC value and was checked again. Failure cases were found where no kernel entry occurred for at least 8 milliseconds prior to the faulting point. Yeah. Next, I mean, there is so much we could and should do, right? Logging the precise instruction pointer, CPU number. Do we still, once we had a patch, do I still have the patch for... Once there was, did they include that in the news kernel to include the most likely faulting CPU? It's crazy how long this compiles here though. Yeah, this of course doubles this if we are otherwise unloaded. Let's see which CPU cores are we running. We next need to rerun this longer. I mean, the other, was it Mesa, right? Did we build Mesa? Alright, I deleted that in the meantime. Yeah, so much to building your professional workstation. So yeah, for those who are tuning in, I run this while thing. So with this while this positive or zero return, echo this, and it would break instantly if it once fails. As we still had with this memory configuration, we still had an error. I will probably, I mean, but this is also already ridiculous, right? We run already with like fully detuned XMP 5600. And obviously we need performance, right? Nothing like, yeah. Could plug in, where do I have so much to, even if I would wanted to capture that, actually I can use so many dongles. Would need, could use this one here, an Apple HDMI dongle, HDMI input here, because that is a DVI. How many dongles will I connect for your viewing pleasure? Was this the right? Yeah, that's the right. Nothing like plugging in a... Is the bitrate even enough? So we have only 5 gigabit on this USB hub. Okay, the build. Let's Control C that. Let's shut down, reboot 0. Let's see, does it dynamically? External video. Video capture. Maybe we need to restart. And there we have that. Although somehow the, what do we have here? Color range. Partial. Does this look? No, this also looks like shit. What do we have here? 120L000. Default, partial, full, whatever. Does not. Looks a little bit washed out. Anyway, all the efforts we do, right? That you see a documenting that here, right? This should it be? Is it? Also, I need coffee. Does this reboot? Should this not? Does it even? Why does this not? I have the feeling this does not work. Why not? It should have captured, somehow it didn't. Too much to dynamically switching. Why does this capture not work? Ah, did I plug in the... No, this is this one. Ah, darn, I just changed the BIOS. I talked freaking to myself. Shit, so much I didn't see that I didn't live stream. So yeah, there was not much to see. Sorry, again, rinse and repeat. I went through the BIOS, like 2023, dump kernel developer YouTuber plugs in an HDMI capture dongle and then forgets to, overlooks to press start capture. But basically, I went through there. No, it's not camera. This was all stock and okay, so now we get image again. Cool. So yeah, this was already all disabled. No undervolt, no overclock. I did it a little bit more manual, normal instead of auto. It's like, yeah, let's see what happens now. So then let's see if it occurs again. Or still occurs. Yeah, absolutely crazy. I probably should. The problem is that it's super long running and you can't do so much in between except for efficiently better change to other work. The problem is if I live stream that, it reduces my efficiency because then I talk and rumble generic IT stuff instead of doing some work. Actually, what does this work? So does it build? So the Linux kernel failed the last 2 times. So let's see if it does again. Of course, performance vastly decreased. And yeah, also so much to AMD microcode, right? Which is the previous video, they don't even release freestanding microcode for consumer, which totally sucks. I should start to pinging them even more. Which stepping is it, by the way? It's already stepping 2. Yeah, another problem is, was it introduced? Because I was previously happily using the system. So was this bug introduced with other microcode fixes, updates in BIOS and AGESA? Nothing like flashing back your last F8, A, whatever I was long rocking BIOS. So many, yeah. I mean, obviously it's not a simple 64-bit micro. You can't easily debug that anymore, right? Yeah, if some issue takes quite a while to reproduce, that certainly sucks. So what would make sense, it would also make sense if I do something else now, but otherwise we could further in parallel, while we wait for this to reproduce, work on other Spark improvements for Rust. Yeah, but the usual thing, like one or not one, but two more things, like one fix there, one bug fix there, and then on top you have some hardware instability that you thought it's surely overclocking and undervolting, and then it turns out no, with stock settings it also occurs. So yeah, it's certainly not a solution to build everything with a randomly internal compiler erring illegal instruction raising thing. Our Linux build now. So what did we further? We further lowered the memory clock. But that's also what I said, right? I said in previous videos, just some random YouTuber building some stuff, just some random YouTuber gaming on Windows is not stressing as much as professional software creator Linux distribution workload. Now my AMD GPU also crashes on the Steam Deck. Use AMD, they... Thank you, AMD GPU. Ring error. Yeah. Cool stuff. Process interrupt, recover, shadow start. What precisely did we hit here? Failure ring, when even was this here? Failed at display topology, DTMT isn't initialized. When SMU unknown command error ring timeout was... This is all right, this is the start of the bug. DRM job timed out. Ring SDMA timeout signaled, emitting. GPU reset. Nah, thank you very much. Yeah. Okay, so far so good. I mean, is this memory instability after all? Which would truly suck. I mean, would that make sense that with my last 64 gigs of memory it worked quite well? And the thing is, everything else works fine, and maybe it's since I have 96 gigs of memory. How long do I have those? Since Eastern already? Also have this already quite some 6 months. Anyway, that's it for this video. Some more detective hunting. I mean, if this builds now, like, then it's... I mean, now okay, one pro tip, I changed too much at once because I don't want to constantly reboot. Probably will still have to constantly reboot more. So I probably can... Does it work to plug out this capture dongle? Does this work and free us with memory bandwidth? Because now I changed, but to be fair, I decreased memory voltage. I could actually see, maybe the memory gets too hot. This is also the thing, right? I was running the memory already with more voltage until I realized I don't need this voltage, right? So much to all the YouTubers and guides and stuff, voltage. I didn't need this voltage. I've run it at times with 1.3. I think I nearly reached 140. Which was working, but obviously getting warmer, which also why I previously wrote the SPD 51 whatever driver. How did we name it? 5118? 218? Don't even know how your own kernel driver is named. You are too busy if you don't remember the name of your own. 5118. What did I try? 51. Ah, I was close. Because then we have memory temperatures. 51. So yeah, that is. It previously reached. So this alarm is persistently stored. Yeah, right now they are... I have already knocked to a fan hanging in the case, right, to further blow air straight onto the memory modules. GSIP. Is not GSIP also? Why did this... why did it build and build? How is this? Okay, we recently updated that, but okay, that is a crazy thing. Just what we fixed in the other package, not really sure why this is only occurring now, although I believe it recently was updated. This is unrelated of other system memory and CPU instabilities. But also my system somehow became warmer, and I don't think because right now it's not that hot in the office. The globally warm summer is over. Yeah, we have below 25 degrees. It's only naturally sunshine 23.5 on this old garbage thermometer. So I'm not sure if my AIO has already lost. Maybe because, okay, so previously I was hovering around that and maxing out at 36, 7, 8. Now I often see over 40, so I don't know what became hotter here. Is this AIO already not cooling as much? Is the thermal paste already drying up? What's going on there? Although I might lifted it up. Maybe I should reseat my, maybe I should re-grease my Kraken and ZXT AIO thing. Because I had to lift it up. I believe I had to lift it up once because what did I do? Did I even cut or bend? I had to somehow modify... Because with the Derbauer offset kit, the AIO metal bracket is too close to the heatsink of the M.2 slot, of the main primary M.2 slot. And I believe I once had to unscrew unscrew it. Maybe I should repeat. Like maybe I could. I would not rule out. I mean, but it should not cause us such system instability. But I would not rule out that maybe you should not reseat your CPU cooler without cleaning and repasting potentially. Yeah. But CPU temperature and cooling should, I mean it could, like if your I/O die gets warm, maybe it could also result in memory instability. But I lowered the memory voltage also, right? But yeah, the best test is let it run, right? Like as you've seen, building something for 10 or 15 minutes is not an indication whether it is stable, similar to Matthew Dillon previously of having to run stuff for weeks and a year. Good that I didn't make a dedicated clickbait video of AMD's CPU park when after all it's only some memory instability. But yeah, you could triple a game, you could build everything else of T2, but you couldn't build Spark 64. Absolutely crazy bug pattern. Anyway, that's it for this video. I hope you enjoyed, learned something. As usual, I don't delay, start patching stuff and sending fixes a day, and I hope to see you soon for the next fun and hopefully a resolution of this last marginality to come.